Welcome everybody to the Big Ten AI Bowl educational series hosted by the Institute for Augmented Intelligence in Medicine, or I.AIM. I'm Abel Coe. I direct I.AIM. I'm joined today by Nan McDonald, who is Chief of Data Operations, and waved there. And then I'm super excited today to be able to introduce our speakers. Let me first mention a little bit about I.AIM though. So I.AIM is based here in the Feinberg School of Medicine. And our stated mission is to bridge computational methods with human expertise to advance medical science and improve human health. But really what we're here to do is to try to build a community interested in informatics, data science, advanced analytics. And our job is to help you, the faculty, succeed in advancing your research. And so we're here to help that through providing education, as well as providing technical and network support. So this is part of a Big Ten AI Bowl we launched this past year, which may not be the best year to launch a new initiative, but it turns out it's actually gone quite well. And we've had the good fortune to have a number of Big Ten schools participate. We've finished an initial sort of semifinals, and then we have a number of teams that will be competing in likely a hybrid event on October 22nd. We'd encourage you to come by and see that, where they will be presenting the work they've been putting together for the past 6 months and competing for a significant significant prizes. So as part of that, we thought it'd be very important to educate not only our students, but various members of our I.AIM community about really key topics in informatics. And I think, I'm biased, I think there is nothing more important in informatics than data standards. When I was training during fellowship, and so myself and Dan and Viet all did a National Library of Medicine fellowship. And we were, I think we all sort of came to the realization at some time in that first few months, some of us took longer to figure this out, that data standards are really the absolute most essential thing in informatics. And so, again, I'm super excited today to introduce dear friends, colleagues, experts in the field. So I'm going to introduce Dr. Dan Vreeman first, and then I'll introduce Dr. Viet Nguyen, who will then lead off. So Dr. Dan Vreeman, actually, he and I both trained at Regenstrief, where he actually then went on to advance. He was an associate professor of medicine there, was director of LOINC. So if anyone's familiar with data standards, that is the terminology standard. I'm sure he'll talk a little bit about more of that that relates to laboratory testing. He currently is a lead for data standards. Actually, let me make sure I get this right, Dan. I don't want to get this totally wrong. So it's Senior Clinical Data Standards Lead at RTI International. And he'll be talking after Dr. Nguyen about I think some about rocket fuel. Is that right, Dan? Something about rocket fuel and standards, I think, is what I recall. And then Dr. Viet Nguyen is MedPeds trained. He also did his informatics fellowship, I think, at Utah. And again, somebody who's grown in his career, and now is the founder and lead for informatics consultancy called Stratametrics. He's also on the board of HL7, which again is an important standards organization within the health informatics space. And so with that, I'm going to pass it over. Dr. Nguyen, you're up.
Thank you so much, Abel. I really appreciate the opportunity to talk to your community. I think the three of us are good examples of pursuing what you love and developing a personal mission around it, and being fortunate to have the success career-wise of pursuing what you love. And so those of us who did informatics 20 years ago, we did it because we thought it was really interesting and cool, and probably had no idea the impact we would make 20 years later. So I'm really feel very fortunate to be in this space with you all. So my topic today is around the FHIR landscape and the drivers for adoption. The goal of this presentation is really to give you a sense of why FHIR and data standards are so important, and how this, in my opinion, and I think many will agree, will be a huge driver of technology, patient care, just any number of aspects of healthcare for the next I'm going to say 20 years, and I think that's a conservative estimate. So just a few things to kind of level set. I know we have probably providers and folks who have been in healthcare for a long time, but we also have a number of folks who are fairly new to healthcare. And I use this slide to level set because U.S. gross domestic product is $21 trillion. That's huge. Almost $4 trillion of that is used on spent in healthcare, which is 18% of our gross domestic product. I use this because if you can wrap your head around the complexity and the size of this, you'll appreciate that there isn't any one solution to improving healthcare, but that it's a collection of solutions. And our role in this particular group is to improve healthcare by making information more interoperable and getting it to really help with the care of the patient and meeting that triple aim. I also wanted to use this next slide to help those of you who aren't familiar with how we compare to the rest of the world. I think there are many aspects in US healthcare that is wonderful. We spend a lot of time and energy and create lots of innovation. But if you look at the Organization Economic Countries, I forgot what OECD is off the top of my head, but it's really comparing us to other modern economic countries. In a number of their health factors, we don't actually do as well. Our life expectancy isn't as long. Our mortality, avoidable mortality, isn't as good. And our chronic disease burden is higher. So as much as we love it, we have room to grow and to improve. And the number that's not on here is that you saw 18% of GDP being used in healthcare. Many of these other countries, it's more on the order of 10 to 12%. So we're spending a lot of money for some of these measures that aren't as good. And one of the problems is really around how we get information within our ecosystem. We have actually a myriad of different data standards and mechanisms to share information. I jokingly say we probably single-handedly in healthcare prop up the fax machine industry. And because it's on every unit of every hospital and probably every doctor's office, because you know when you send a fax where you're sending it to. We still use a lot of paper. We still have a lot of phone calls and help desk. We have some movement over to kind of portals and websites and things that are helpful. And we exchange data today in a number of different formats from electronic data interchange all the way to XML. And these formats are working, but they aren't really future-proofing us for a dynamic and agile healthcare system that we need in the future. So how do we get to that? We get to that through a number of approaches, and the federal government has been one of the drivers to getting us to the future healthcare system. Abel shared this slide with me, and I think it's really great because this really summarizes a number of regulatory activities that the US government has, as well as investments, particularly the HITECH Act, to try to get us to this future state around privacy, around adopting technologies like EHRs, adopting standards, which is what the Office of the National Coordinator is trying to do, the movement towards value-based care, which is what this MACRA legislation has done for us. And in particular, and what I'll cover next is really some of the recent regulatory activities that are driving the adoption of interoperability as part of a three-pronged approach that the federal government has around healthcare. One is improving transparency of information for patients and the costs, improving quality of care and measuring that quality, and improving interoperability as a leverage to achieving those goals. So we're moving towards value-based care. And for those not familiar with value-based care, it's the notion that you are incentivized and are reimbursed because you're developing high quality care based on the best practices and quality measures, as opposed to getting paid for what you do, which is what we call fee for service. So value-based care really requires the free flow of information, of course, security and privacy on top of that, but that free flow for the right stakeholders, for the patient, so that we can actually measure how well we're doing. So this future ecosystem, and the reason why I think I'm here today is to help talk about the role of FHIR. And really FHIR is the future of how we're going to share information. It's really going to be the basis for which we have the data models to share information, as well as the APIs that will allow us to do that. And really, FHIR started out focusing on the clinical domain, but as you'll see in a little bit, we've really started to look at how we can use FHIR for administrative purposes around payers and provider interactions, as well as with research, social determinants of health. So it's really starting to become more and more pervasive throughout the health IT ecosystem. I used to say that in the past, 8 or 9 years ago, people asked me, what's FHIR? And then after they heard about what's FHIR, they asked me, why FHIR? And I had to explain why FHIR was so important. And then they asked me, once I convinced them the why of how am I going to do this in FHIR? And finally today, it's about when, and when is now. Because in order to achieve this ecosystem, we need to do this in a thoughtful approach that I think has been led by both the healthcare IT community as well as the federal government. One is the adoption of standard data models. 20 years ago, when Abel and Dan and I were training, I did actually a VA fellowship, and we had a slide deck. We called it the state of the state, and that's because every VA hospital had a file that had the 50 states and all the territories, which would be great for the 56 rows of that file, but every site was different beyond that because it wasn't standardized beyond those 50 states and territories. So local sites were adding their own locales into that file. And so we had a deck that we call the state of the state deck that we would go and try to promote interoperability. Fortunately, I haven't had to use that for a very, very long time because now we're starting to standardize. So we have standard data models. We have FHIR to give us standard APIs and ways of using these APIs in applications within the EHR. We have what we call implementation guides with FHIR, which is kind of recipes or standard operating procedures to implement FHIR. And so those are all in place and continuing to grow. But along with that, we have implementation of FHIR by the EHR vendors, by payers, by HIEs, and by the vendor community that develop applications. But so we're doing all those things. But the next step that's really going to be important is how do we scale this to the entire ecosystem? And there's the ONC FAST initiative that I'll talk a little bit about in a little bit that's helping with that. And then now that I've talked about the when of FHIR, I'm starting to ask people, so what's next? And what's next, I think, is the value of what your participation in this AI Bowl is. What can we do with that data? How do we improve quality measures? How do we do better clinical decision support? How can we do AIs? And then Dan's going to tell us about some of the challenges today on that and what are the opportunities as we start to standardize our data so that you can really start to scale these new technology and innovations you're all working on. So again, what is FHIR? I showed you the acronym, but it really stands for Fast Healthcare Interoperability Resources. And FAST is because to learn about FHIR and actually implement it in my consultancy, I can get an organization and a set of developers developing their first FHIR app in under a day. Getting it implemented in EHR takes a little more time, but really understanding the core technologies is not that bad for developers who are trained kind of in the modern era with APIs. And so implementers can implement it fast, but that's only part of it. Understanding how it fits into healthcare is practically much harder. Understanding workflows, understanding the data and how it's used in delivery of care or in administrative purposes is where informaticists really come in, and the subject matter expertise in these workflows are really important. Of course, the core is interoperability. How do we share this data in an interoperable way, not just the data itself, but in APIs that are predictable and implementable by developers. And then at the core of this are these resources, or data models. So I don't go into a whole tutorial on FHIR, but really the key is to understand that it's a set of data models and a set of APIs, much like what we use for travel or for e-commerce. And those are the two industries that I point to when I talk about FHIR with executives. 25 years ago, we had to use travel agents or corporate travel offices to help us travel. But I don't think I've talked to a travel agent in 15 years because we have all these websites and corporate travel tools that allow us to do the simple things like determine where the dates of travel, where we want to travel, and then automatically get a list of airlines and hotels that are available to us. So the idea of these APIs are really, we're taking human processes and we're handing it over to these APIs to do the drudgery of looking up, availability and then bringing that information back to us. But on top of that, and the travel metaphor is really good, we can make this more dynamic, this interaction. I'm not using a paper itinerary. I'm using my phone API and my phone app to know if my flight gets canceled or delayed. And these are the opportunities that APIs give to us. And this year, 2021, we're celebrating the 10th anniversary of FHIR. So it's not new, it's not emerging, it's here. And the key things are that we have all these FHIR accelerators, Da Vinci project being one of them, that I'm the technical director for, are really starting to adopt FHIR in these workflows and developing implementation guides. A key milestone is this adoption, of the FHIR R4, the publishing of R4, which is the first FHIR version that has normative content, meaning it won't change. And if it needs to change, it will be with great hesitation, because it needs to give the implementer community a certain sense of certainty about FHIR. But what we need to know is that FHIR is an evolving and maturing standard, so it's always maturing. There are components that are normative, but there are components that are being introduced all the time and getting matured through the process of standards development, implementation, and that feedback rule. But the other important thing, at least for me and my community and the people I work with, are all these federal rules. ONC, the Office of National Coordinator, has defined a bunch of rules around certification of applications and vendor platforms that identify FHIR. We have CMS, which oversees kind of the federal programs, Medicare and Medicaid, and the ACA marketplace that requires the implementation of FHIR by both payers and providers. And in the future, we'll even have quality measures that have been identified to use FHIR. So the US, the regulators are really pushing the adoption of FHIR from the clinical care, but in the conversations I have with them, they're also looking at using FHIR in the FDA, in NIH for research and other domains. So it's getting adopted more and more. I use this slide really to help executives understand, because they still think that FHIR is kind of this new thing. It's not new. It's been around 10 years, as I've mentioned, and 96% of hospitals in the country have FHIR-enabled EHRs. Granted, they're version 2 FHIR, but they're actually rolling out, and one of my clients told me that their version, their EHR, has FHIR R4 already implemented, so ahead of schedule. So the key here is to let you know that if you're going to develop applications, you have a market to sell it to. And so these hospitals have FHIR-enabled EHRs mainly because the top 5 EHR vendors in the inpatient space control over 95% of the market, versus the outpatient market, where there are more EHR vendors, and there are a lot of clinicians who just don't want to use EHRs at all. But the key here is to know that there is a marketplace to sell applications that are FHIR-enabled. Along with that, here is just to let you know, the Epic and Cerner I reference here are FHIR-enabled, and they have tons of institutions. The numbers are different because it's how they measure their institution, whether or not it's one EHR instance for a whole healthcare system versus individual offices having their own instances. So that's the difference there. But also all the major cloud vendors have FHIR offerings and are working with payers and providers to do that transition into FHIR. And one of the really significant things, and things I love because I happen to have an Apple device, is that Apple was one of the early adopters of FHIR and Smart on FHIR, and they implemented it in their health kit. And one of the clinical leads at Apple is actually a colleague and a cohort of ours. Why am I blanking on his name? Abel, remind me, Ricky Bloomfield, sorry. And he was part of the group with Abel and Dan and me in the early 2000s, and now he's leading this kind of effort at Apple. And one of the examples I want to describe here that is an example of how well FHIR works is my example with COVID. I was able to register for a COVID vaccine back in March when it was available here in Utah. All I did was register on the state website, went to my appointment, they confirmed my information on an iPad, gave me my immunization and my card. And after the second immunization, I thought to myself, I wonder if I made it to the state registry for immunization. So it turns out Utah is using an Apple app, and I was able to find it on there. And my second question was, I wondered if it made it to my health kit. So I went into the health kit, logged into my Intermountain Healthcare My Health portal on the health kit, and there was my immunization already there with no intervention from me at all. And not only that, if you use the health kit, you can actually see the FHIR resources that represent my immunizations. It identified that it was Moderna, the lot number, the SNOMED code for where it was administered in my arm. All this information that then I was able to use, because I was planning on going to HIMSS but didn't, to pass that over to CLEAR, that we use at airports, because HIMSS was requiring a vaccine certification. I'm not going to call it a passport. And it was able to pull that information straight from the health kit. So that's an example of how FHIR really is making the data much more fluid for its various needs for patients and for others. So the key things to know about what you can leverage with FHIR are these ONC technical standards that are adopted as part of the 21st Century Cures Act. Number one is that the ONC requires that health IT certified applications are going to use FHIR R4. So if you looked up this FHIR R4 version, you'd know what was available. But it's not all of R4. It's going to be a subset of R4 that supports Smart on FHIR, app launch, OpenID Connect for identification, and most importantly, for us in this conversation, is a set of vocabulary standards. So this first set of version 1 of the US core data for interoperability is part of this requirements, and they've already published the version 2 of this. And the subset of the US CDI, which is a set of classes like demographics or medications and things like that, are representations of those in data standards like LOINC, SNOMED, and in particular the US core FHIR profiles. So that way you can know that if you're requesting a medication from an EHR or FHIR-enabled endpoint, you're going to get back a particular FHIR data model called the US core, say medication resource. And that makes it much more predictable and allows you as vendors or app developers to create one app that should be working across all these different platforms, EHRs and payers. Along with that, CMS has identified FHIR and put requirements for certain payer groups, for those on Medicare Advantage, qualified health plans, Medicaid, to use FHIR to allow patients to access their clinical data. So if you're a Medicare Advantage beneficiary and you used Humana or United, you could have an app that allowed you to find out all your claims information and your clinical information. And then you could also look up all the providers in your directory on your plan. You can pull up your formulary information and look at what your formulary, your tiers are. And in January, there are going to be requirements for exchanging data from payer to payer. So if you go from one payer to another payer, you can take your clinical data with you if you're on these plans. And really the strategy here is that if CMS, with their authority, require their payers to do it for Medicare, Medicaid, and CHIP beneficiaries, the leap or the incremental resources to make this available broadly for commercial is pretty low. So that's how they're really driving the industry. And there are additional regulatory activity around doing prior authorization, which is very burdensome to providers. And then we have work that have been in some proposed rules around getting the same FHIR data from payers back to providers. And why is that important? It's important because a given patient may receive care outside of your organization and you won't know, but certainly the payer, the insurance provider for that patient is likely to know because they're paying for it. And so how can the providers that are primary care providers get all this information from specialists who might be out of the your actual healthcare organization? We'll be able to do that via FHIR. And then one that's I just had a call just earlier this morning. That's a really big hot topic in healthcare right now is this Consolidated Appropriations Act and the No Surprises Act, which is requiring providers to give the patient a good faith estimate on scheduled services like a surgery, and then working with a payer to return to the patient what's called an advanced explanation of benefits, so they know what the likely cost of the service is, the surgery is, so that they don't get a surprise because there is a non-network provider that participated in their care. We hear these stories all the time about patients getting a bill, months after their procedure from somebody they didn't even know was involved, and now they're on the hook for this, for paying this. And so we're developing some FHIR implementation guides to help share that information between providers and payers, and then getting that information back to the patients so that they can be more aware and engaged and part of their own care and making decisions. I want to note that there are a number of communities that are really picking up FHIR. So FHIR, again, is a set of APIs and a set of resources, but that's like having a kitchen with a bunch of ingredients and you have kitchen tools. It doesn't really make you a meal. So these different FHIR accelerators are comprised of subject matter experts from provider, payer organizations, pharma, that come together to look at particular workflows so that they can develop implementation guides for certain workflows, like prior authorization, like enrolling a patient in a research study. How can we use FHIR to collect data, to share data, to aggregate data? And so Vinci is the one I work on, that involves the providers and payers. Excuse me. Codex is focused on oncology. So how do we represent oncology protocols and sharing of information for staging and things like that? Gravity is looking at social determinants of health. So if you're not familiar with that, that's really important. These are the factors that affect the patient's ability or individual's ability to access care and be able to engage in the healthcare system. Excuse me. If you're a researcher, you want to learn about Vulcan, which is looking at how we use FHIR for clinical research. It's a lot of engagement by academic groups as well as pharma. Karen is focused on patient or consumer to business interactions. And then the Argonaut group was an accelerator before there were accelerators that are really building out new capabilities in FHIR. They're responsible for the Smart on FHIR, CDS hooks, and something called bulk FHIR. So how do we share data at scale using FHIR? And then putting it all together and trying to figure out how we scale this is the ONC FHIR at Scale Task Force, which works with these FHIR accelerators to look at common requirements that each of these organizations and stakeholders would need in order to scale FHIR, like identity management, directory services to find FHIR endpoints. How do you deal with multiple versions? How do you scale this at a national level and do testing and conformance, and not the least of which is security? How do you secure this information so that we don't have breaches? So this is a really important aspect that is reached a level now that they're doing implementation guides and balloting, and we look to do pilots later this year and next year of some of the Vinci implementation guides around this. So with that, that was a lot of information. I'm going to stay on while Dan's on, but I'm going to go on mute, and then we'll have some time to chat. So if you have questions, feel free to put them into the chat. I'll try to answer them as I can, and if we can have some verbal questions as well. So handing it back to you, Abel and Dan.
That's great. Thank you, Viet. So Dan, as you put your presentation, actually, we might have time just for a quick a question while we're during the transition. So Dr. Teji, I think, and Sam may not be on anymore, but Dr. Teji had a few questions, I think, that are in the Q&A section.
Q&A, okay.
So I think, one of Dr. Teji's questions was, what is the measurable outcome goal? And I think it may have been related to one of the specific slides. So maybe, let's see. Actually, maybe that that was maybe specific to a particular slide of yours, though. So maybe we can actually punt that. And I'm looking at it now. Maybe we could delay that. But the other points, the slides will be available. The recordings will be available. The links are all being put in there. And so maybe we'll actually hold on this now that Dan's got his slides.
Yeah, let's address that when we after Dan's done, and we can have folks clarify the question. But thank you. Back to you.
Thanks, Viet. Dan, you're up. Thank you.
Great. You seeing my slides all right?
Looks good.
All right. Thanks. Well, I am really delighted to be here. It's great to share this experience with two close friends and colleagues. And I am going to be talking a little bit more about kind of the additional complexity to some of the things that Viet was presenting. I'm going to refer back to and kind of highlight a number of the points that he made. But what I wanted to spend some time thinking about was how to unlock meaning from health data messes. And of course, standardization is one of the key techniques for that problem. So if you are coming from a data science or computer science background and trying to apply your knowledge and skills in the healthcare space, not unlike other complicated areas, I can guarantee you will be thinking, man, some of this data is a gigantic mess. And sort of the more you dig into it, the more messes you find in the nooks and crannies of the kinds of information that are actually very, very important to clinical care, as well as for all of the other purposes for which healthcare data is used. I'd like to give you some examples of this. Viet did a wonderful job explaining sort of the key drivers around and the importance of API and data model standards like FHIR. But inside of standards like that, there's kind of another dimension of messiness. So here, for example, if you were to sample key clinical measurements from a number of healthcare institutions around, what you might find is inside of those systems, the same exact clinical measurement is labeled in various different ways. So this is just a sampling from care settings around the Indianapolis area for something like a diastolic blood pressure measurement, kind of bread and butter. But across those systems, there's very, very different ways of referring to this, which for humans, looking across things, you can more or less figure it out, particularly if you have that kind of domain expertise. But it's actually quite tricky for computers to figure out across these catalogs of variables, which ones are really the same and which ones are meaningfully different. This same problem exists all over the place. So here, for example, a single lab test and the ways in which it is identified in different computer systems, different healthcare systems, across a geographic area. Here you can see the same kinds of variations, both in terms of the identifier as well as the descriptor for that test. Even something as sort of straightforward and simple as you might think, which would be units of measure, we see this kind of variation all over the place. What I'm showing you on the slide is a collection of all the different ways the units of measure for a single laboratory test, platelet count, is represented in an aggregate pool of data. And you can see there is a lot of variation. It exists in areas such as radiology tests as well. Here I'm showing you a few examples of different tests or different codes, so same test, different representations, all for within the same hospital. And you might ask, well, why would that be? Well, there are a variety of different reasons, including, for example, that they may be using this thing like this code to distinguish between the same procedure performed at different locations within the institution. So this kind of variation is all over the place, everywhere you look in healthcare. For those of you young bloods, you may not recognize this reference, but for us old timers, the 90s hip hop song, Mo Money, Mo Problems, is something I like to use as an example to say, the more data you get, the more you aggregate across different healthcare institutions, the more trouble you're going to find with this same sort of proliferation of variation. My question to you, as we think about this in the context of computational methods, is really, how is this kind of variation, this variability, going to affect the performance and generalizability of your models? So we're going to try to dig into these two aspects just a little bit, but this is sort of my prompt for you to continue mulling over. So as Viet described, of course, in order to make sense of this kind of variation, we have to agree on and use standards. And there are two big kind of categories or classes of standards that I like to talk about. The first is what you might call syntax standards. These are standards that describe the format and the structure and the organization of the information. And inside those syntax standards, semantic standards or vocabulary and coding standards are what's needed to identify and share the meaning of these different clinical concepts. And here there's a whole collection of vocabulary standards that are really important to understand and be aware of in health data. Just as an example, to let you know that this isn't just my opinion or Viet's opinion or Abel's opinion about this, the Office of the Chief Technology Officer for HHS convened a roundtable not too long ago trying to sort of summarize ideas about how to share and use health data in AI applications. And one of their key recommendations was this exact point, that we have to use standards in order to improve both the data quality and interoperability of the health IT solutions that we are building. In that roundtable, they identified a couple of key kinds of information in health that are particularly interesting for AI applications. I've shown a few examples here. We're going to dig specifically into clinical data a little bit more, but just thought I would mention that there are certainly other kinds of health-related information that can be applicable for these kinds of methods. Now, Viet mentioned this thing called the US CDI, the US Core Data for Interoperability. It's a Office of the National Coordinator developed set of key health information that's now part of regulation and is the backbone of what is becoming available by health institutions using FHIR because of these regulations. I wanted to sort of lay out this landscape for you. You can see the different types of health information, things like allergies, things like clinical notes, medications, laboratory tests, vital signs, et cetera, but also to show you that there is quite a range of terminologies that are identified as being important or adopted, accepted for these different kinds of information. So, for example, medications with RxNorm, laboratory tests with LOINC, problems as ICD, SNOMED, et cetera. So across the health landscape, these different kinds of data, not only do we need to understand the structure that they might exist in, but we also need to try to understand a little bit about the ways in which the content can be standardized as well. So I wanted to just use laboratory tests as an example for illustrating some of these points. In the US CDI, in the US and elsewhere around the world, the vocabulary standard that's been adopted for identifying those tests is called LOINC. It is a freely available universal standard for identifying health measurements, observations, and documents. And it's constructed in such a way that each term represents a distinct clinical meaning. And so each term is meant to separate the things that have different clinical meanings and group the things that have the same clinical meaning. It's like FHIR, available for free around the world. Importantly, it comes with it is some implementation tools, but even more importantly than the tools, both for FHIR and for vocabulary standards like LOINC, is the diverse community of folks that are working together to use it and to continue to make it better. Today, there are roughly 100,000 or so users from about 185 different countries, and therefore there's some great uptake. Together, FHIR and LOINC are like chips and salsa. This is how I try to explain it, meaning FHIR is the perfect delivery vehicle for serving up rich LOINC-coded laboratory and other clinical measurement information. So to illustrate how these two things go together, I'm going to share just a quick example of an observation resource. Over on the right-hand side is an instance of a FHIR resource, a particular laboratory test for a particular person. In that structure, FHIR defines sort of a data model, as you can see, and as we had described. One element of that data model is meant to hold the thing that tells you what is this measurement. And that's where LOINC comes in. So over here on the upper right-hand side, you see a code and display name for this SARS-CoV-2 antibody test. Now, there's another place in the data model that holds the actual result value, and it holds the units of measure that correspond with that. But it's the job of the terminology standard to help the computer identify and distinguish among these kinds of clinical measurements. So LOINC is perfectly suited for fulfilling that kind of a role. So how does that relate to you as a data scientist, you as someone who might be developing or using advanced computational methods like machine learning, AI, et cetera? I wanted to illustrate by using this case study paper. I think it's a really interesting example. I haven't seen it replicated a lot in other domains, but I would suspect that the findings will hold true, and it might be up to you to conduct some of that work. In this paper, the researchers were trying to answer a central question, which was, how good or how much better can my model be if the data is standardized versus non-standardized? And particularly, they were focused on this question because they noticed that in most of the predictive modeling studies they've seen thus far that, for example, use laboratory data, those studies really didn't describe at all the standardization processes used, and that left some things to question. So the approach that they took was to try to get a better understanding of how standardization, for example, mapping those local laboratory tests, which might have a whole bunch of different representations, to a standard terminology, i.e. LOINC, when we're doing predictive models with multi-site data. So the general approach that they used, they were looking to predict 30-day hospital readmission. I don't think the particular outcome measure matters so much, but they extracted data from multiple hospitals and were using a variety of different techniques to learn the models. And they were basically setting up to evaluate and compare the performance with sort of unstandardized data versus standardized data. And what did they find? Well, more or less, across every classifier that they used, whether it was logistic regression, naive Bayes, or random forest, at every point, the standardized data had improved performance. The authors will be quick to point out they weren't trying to create a hyper-optimized model, so the exact sort of AUC value was not the thing that they were focusing on. What they were focusing on was same data, but either standardized or unstandardized. What effect did that have on model performance? So the authors say, hey, you know what? This actually makes a big, big difference. And we demonstrated that and the positive impact that having standard codes can do, and want to see additional work in terms of researchers describing these standardization procedures in predictive modeling studies, especially when the data sources are being combined or aggregated from multiple sites. So that sounds great, makes a pretty reasonable case, but I also want to share some caution with you about this mapping process. The main point I want to emphasize is that transforming or identifying the local representation to a standard code is not a trivial thing. Unfortunately, the use of standard terminologies is not completely ubiquitous in the healthcare market. Now, we're incrementally improving all the time through regulation and other pressures, but you may very well find yourself in a place where some of the data that you want to use is not yet mapped, or in other cases, the mappings are not available to you. For example, in many institutions, that mapping might be stored as part of the interface that makes the API available. But if you are accessing the data from the data mart or the data warehouse, that mapping table that links those local terms to the standard terms may not be available in that environment. So there's work to do. But also, I want to caution you that this is not really fundamentally an IT problem. This is actually a sort of a domain knowledge problem, where somebody who really understands what these measurements are is the one that really kind of needs to be able to do that mapping work. Although it's tempting to sort of think of it as a purely IT problem because it's like, hey, code list here, let's just try to line them up. But the other thing that makes this mapping and linkage to standard terminologies really hard is that a lot of times the incentives don't line up properly. What I mean by that is the people who actually really have to invest the energy and the resources to do the work aren't the ones who reap the rewards. Of course, the benefits accrue to those downstream, whether that's those who are aggregating data for public health purposes or for research purposes, or maybe you as a data scientist. But the lab or the sort of input person who is in charge of that may not sort of directly see the benefits of that standardization work. And therefore can be tricky to get that sort of value proposition correctly aligned. The other thing that makes this terminology stuff hard is that our world is constantly changing. And it's really important not to think of interoperability as an endpoint destination, but really a progression, a journey towards and improving and continually keeping up with the standards and the representation of health data in that way. For example, in the early days when we were starting the Indiana Network for Patient Care, the Health Information Exchange around central Indiana, we looked at how frequently the test codes sort of changed in that exchange. And when we went live with an institution in the Health Information Exchange, meaning they were sharing data and contributing it to a number of the other network participants, we went through and we had mapped everything in their entire test catalog, every variable that they had. But then in the study, we went and looked and see, well, 2 years out, how much really changed? And it turns out that half of the terms from that initial set turned over in just a 2-year period. And there are all kinds of reasons for this: new tests, new instruments, new acquisitions of additional health facilities, all kinds of reasons why this happens. But the point I'm trying to make is that that data representation is not static, and that just because it's done at one point in time, tomorrow things might be different. But recognizing that this problem of getting local derived information represented as standards is a challenge. A number of years ago, we actually tried to use the machine learning techniques to help address that problem. And it turns out that supervised machine learning was actually pretty much the best available technique that we had found, and demonstrated that in this paper. But one of the interesting things was that it couldn't do everything. So it's like you still needed humans, but the nice thing was that using the performance characteristics, we could identify a pretty reasonable subset, around half of the tests, that the algorithm could pretty confidently find the right standard term for. And then we could flag the remaining ones for the human, the subject matter experts, to dig into a little bit more deeply. So I've been thinking a little bit about the impact of that variability on model performance. I want to spend a little time as we wrap up thinking about the generalizability question. So the role of data standards, the format standards and the vocabulary standards, relate a lot to the generalizability of input data that you might feed to your model. But I also want to emphasize that there is another aspect of generalizability that Viet was starting to touch on, and that is really actually of the increasingly available pipelines and tools that you can use if you assume and have access to a standardized set of input data, i.e. data available via FHIR and coded with standard terminologies. And that's due in large part to the fact that all of the major cloud vendors and consumer IT companies have fully embraced FHIR as the default representation of health information for their cloud-based platforms. So I'm showing here, a public statement from Microsoft, Amazon, Google, and many, many others in their support for FHIR. And what that means to you is that these commercially available, sort of ubiquitous cloud provider services all have native support for working with data, health data that's represented in FHIR. Here's an example from Google, speaker EL from Google, who's live demoing at a FHIR conference the pipeline that helps take input data represented as FHIR JSON structures coded with LOINC terms and feeding that into Google's cloud platform, and makes it sort of instantly searchable with BigQuery, this warehousing platform that has built-in machine learning tools and so forth. Similarly, Amazon's offering called Health Lake has a really robust platform for doing machine learning models and so forth. And but the input of health data into that learning platform is built on and works perfectly well with FHIR formatted data. So the standards help with the generalizability of the tooling and the sort of platforms on which you can do your work. But there's one last dimension that I wanted to touch on, which is if you're thinking about how the algorithms that I might develop and test might scale or be deployed in live systems, that's another aspect of generalizability that, of course, is greatly helped by the fact that those models can be trained on and built on data represented in a standard format that you would see and is actually available in health institutions around the country. And for example, that was one of the main points of this paper that I thought was really, really fascinating. This is now a couple of years ago, but it was pretty novel at the time. It actually came out of the Google Brain group called Scalable and Accurate Deep Learning for Electronic Health Records. And the main idea that they were trying to explore was the fact that they could use the entire health record if it was represented in a standard format and apply sort of deep learning methodology to that source rather than sort of pre-selecting a set of structured predictor variables and feeding those things into a statistical model. And in this paper, they sort of demonstrated their ability to sort of do that across a pretty wide range of predictions. But the input source of that was FHIR represented electronic health records. And in these models, they outperformed basically all of the state-of-the-art predictive models that existed at the time across a wide variety of things. And typically those models produced more accurate predictions and produced them earlier in, say, the course of a hospitalization than our current approaches. But what I emphasized was not to you today is not per se the accuracy of these kinds of predictions, but rather the fact that they were able to pretty easily use them at multiple institutions because those institutions' data were represented in a consistent way. And that's the value of standardization. So if I could wrap it up in one sentence, what I try to leave with you is the idea that clinical data, when it's coded with vocabulary standards and made accessible with open APIs and data models like FHIR, that really is like rocket fuel for your advanced computational methods. It's purer, cleaner, burns faster, and will help make you more successful. So thanks very much for the opportunity to speak with you. And I think we probably will turn it over for some Q&A.
Fantastic, Dan. Thank you. Thank you both. Dan, Viet, fantastic talks. Really appreciate it. And there are a bunch of questions actually in the chat. Actually, I wonder, Nan or Meg, is there a way to unmute some of the question folks, just because some of the questions are a little more complicated? There might be some context there that we might want to sort of talk through real quick.
We can definitely unmute. Who would you like to unmute?
So it looks like the first question I see that is coming in from Saranga. So we all know. So Saranga, maybe we could try to unmute Saranga. He's got anything that's more than like one or two lines. We're going to unmute you pretty much. So Saranga, go ahead.
Hello, can you hear me?
Yes.
Yes.
Awesome. Thank you so much. This was a great presentation. Really enjoyed it. I think I'm basically trying to take the next step beyond some of these standards and try to understand, and along to the line of the Google research, how do these standards translate effectively to represent and communicate how a machine learning solution should be either deployed or represented? So for example, within the OMOP community, they have the ability to train a patient level prediction model and then share it across other OMOP environments. Michigan has something called the MCBK community where they build standardized what they call knowledge objects. Has there been any work on creating formal standardization approaches of an AI tool to basically represent, to represent how the models look like, what the internal rule sets are, and then how they should be trained?
So I'm gonna try to answer that by saying, when I said about at the end, we're at the when is now, and what's next. What's next is actually the leveraging that data. So I've actually had a number of companies come to me and ask, well, what are the analytics opportunities? And I said, they're all there, because we don't have these standards. We've been working, like Abel said, we appreciated terminology and standards in the early days, and now everyone's caught up. And now you got to figure out, how do you standardize workflow and analytics using this? And so there are huge opportunities to develop approaches and help to standardize, potentially APIs around using this data for AI machine learning. I don't have that expertise because I'm not an AI person, but there's certainly a need out there.
And Saranga, just to add on that, the work that Michigan's doing, I think Rachel Richardson is doing some of that work, is really, I think, pretty exciting. The concept of like sort of almost like bundling knowledge objects. There's also been work this summer. There was an NIH workshop about I'm going to paraphrase it, but it was like electronic health records for AI research. It was something like that, and it was It was organized by National Library of Medicine. So someone near and dear to us was Patty Brennan and that whole team. And the conclusion of it was that there is a lot of work that needs to be done, but it always has to go back to the data. And so there was a lot of issues that were brought up about how well the data represents a population. So trying to understand things around bias and provenance and quality and standardization. So the unfortunate part of it was I don't think we had an answer at that time. There was even things about consent that came up. So how do you ensure that even the data as it's ingested also has the appropriate sort of controls in place that goes all the way back to the person that generated is responsible for that. So, but suffice to say that that report that Dan put forward for 2019, that work continues. Those conversations are continuing, and at very least, what we can do is at least get to the now. So, and I would argue that the vast majority of the world, unfortunately, is still running to catch up to the now. Is at least it may reflect some of Dan's description of the messiness of the data today. So, but I think it is an important point. Dan?
Saranga, you ask a fantastic question. The only thing I would add to what my colleague said was, I've been interested in Google's model cards specification, which is not a standard per se. Perhaps it could become one, with more community input, but it gets at some of the things that Abel was talking about, which is how do you have kind of a consistent representation that organizes kind of the metadata about the model. It's like, what was this trained on? What were its characteristics? What were, for whom was it applied? What are the outcomes? And so kind of a specification that outlines those sort of key attributes. And so I think that's very promising. I think the community probably has a lot more work to do in terms of thinking about how should we represent that kind of information. But I actually see that as a pretty immediate next step, meaning I think in the relatively near future, there'll be a lot of interest in taking that for exactly the reasons that you brought up, which is how do we get to really shareable knowledge that way.
And there is a bunch of questions, and I believe Dr. Teji is here at Lurie Children's Hospital. We've not met you before, but let's try to unmute him because he has a number of questions, and maybe he can choose whichever ones and sort of present.
Yeah, hi. It's really a pleasure to listen to all of you. It's a wonderful opportunity. I asked the question when we got EMR in Mercy, which closed now, but I'm with Lurie, that, hey, we started in 2008 with the Cerner, and the first question was, hey, how do I do analytics? And they looked at my face, we haven't even started this yet. Anyway, in the pursuing years, I did small projects like what type of feed, time of feed of newborn babies, and it was quite a task. I had 12 meetings with IT. Then as the program upgraded, we had to upgrade those. But then I looked at data from the nursing staff, what they put in. So where they put it in. So this was a joint learning program. This is what I put in my chat. It's a multi-pronged thing if you're going to make it work. After all is said, it has to be clean data. And people have to be well-versed with how important is this data. That's a given. And if they're not, you're not going to be able to do it. And my question about infant mortality is because that's the index of health for every nation, that ultimately, is it going to achieve lower infant mortality rate?
Well, to me,
I know it's not just mother-baby thing, it's the whole population.
Yeah, that's like an outcome. And so as
Yes.
I look to how do we use FHIR, there are a couple of things I'd love, because I'm assuming you're a pediatrician.
Yes.
Number one, EHRs were developed mostly for adults. And so
Right.
that's a problem. And so
And not for physicians either.
Yes. And so some of the opportunities that I try to promote, I've been trying to push the community, because I can't do it by myself, is take a look at our newborn assessment form that looks pretty much the same across every hospital, but not quite the same. But the data elements are pretty much the same. If we were able to standardize that through the AAP, say, and we could use that model and the profiles in every EHR and every hospital that delivers babies, how much could we improve interoperability of that data that goes back to the primary care pediatrician? 4 million.
Absolutely.
4 million.
That data goes to the birth certificates.
Right. But an example of how we've actually implemented it that's very useful to pediatricians is that growth charts are pretty crummy in EHRs, or have been historically. There was a recognition of that. And so the SMART group in Boston created a Smart on FHIR app that took the data from the EHR and plotted it on the CDC growth chart, and made an app that improved the functionality of the EHR. It came here to Salt Lake, and the folks at Utah took it and showed it their pediatricians. They liked it, but they said, well, I don't like the CDC's growth chart. I want the WHO growth chart. And all they had to do was change the overlay and make a drop down and allow the pediatricians to pick which one. So those are the opportunities, I think, that I call developing EHR 2.0. Advancing the functionality of the EHR for data visualization, information capture, things that aren't being captured, like in PEDS very well by an adult EHR, by developing and implementing Smart on FHIR, and then adding clinical decision support through things like CDS hooks and other technologies that can then be shared between an Epic system, a Cerner system, and another system, because you've used standard data like FHIR.
I agree wholeheartedly with you. When I talk to people regarding this, they say, well, every program is different. They don't understand. It's the data we are concerned about, not the program. And that concept needs to be driven home. Enjoying your program.
Thank you.
Yeah. And actually, I want to make sure there's some time. I know we have some student teams who are on. And so we've got Dan and Viet on, and so if any of the student teams have any specific questions relating to data standard interoperability that relates to their projects, this would be a good time to ask it. Or if or if people who are out there, we were on a call this morning in our Capricorn meeting talking about data standards and RX norm and ingredient level mapping and all this kind of stuff. And this is a good crowd to ask those questions about, just in case someone has any specific data questions. So I'm going to leave it open just for a second here. If anyone has, any of the student teams have questions.
Yeah, Abel's bringing us in at the friends and family consulting rate. So.
And you can use the raise hand button to indicate that you have a question that you want to ask.
Right. And while people are thinking of that, you can either type it in. I will also ask just two questions on behalf of students. Dan, this is for you. You talked about how this is a journey, right? It's not static. So you've been involved deeply in development of standards. And so if you had a message to students or people who are training coming up, like who are developing their latest research, latest science, what would you say, like, what would be your advice to them with regards to standards? Like, Like what would be sort of like your takeaway for someone who's just starting out in research?
Yeah, thanks, Abel. That's a great question. I hope we've done a little bit to sort of convince you that this is a fundamental, kind of a baseline opportunity that is going to help accelerate whatever you want to do. When Abel and I started, I was super excited about designing fancy interfaces for clinicians. And it wasn't until I realized that, gosh, man, the computer can't understand anything. So how can I make a great display? The same thing would apply to whether it's analytics approaches or whatever. Just recognizing that that's a fundamental part of it, I think is a really important first step. The second thing I would say is that standards, we've had standards for a long time, but one of the key things to recognize about them is that they are like they demonstrate the network effect, which is they actually become more valuable the more people that use them. You saw from Viet's talk how there's a rapid growth curve on that, which is a fantastic opportunity. So recognizing that the more people, the more systems that are out there using something, you can derive added value from that. And the third thing I would say is just recognize that standards are actually communities of people more than they are technical specifications. And you might very well be working in an area, say you're interested in sensors and the data that comes, related to mobility or whatever. And the data representation might not fully meet your particular use case. These aren't like static things that are like published in Encyclopedia Britannica. Nobody knows what that is anymore, like a thing that sits on your shelf, right? They're living, breathing things. And the communities are intentionally designed to be open and welcoming. And we hope that you would find it that way as well. And you have the ability, even as a brand newcomer, to make contributions, to share, and to help improve that for the benefit of all. So don't be shy about getting involved early, and hopefully you'll find it a rewarding way, even if it's kind of not your primary interest, as a way to help scale and spread your ideas.
And I love that, Dan. I think that idea of community. It's funny. I think when you start out in this field, you're so enamored with the technology and the latest app or what have you. And then I think all come to realize that really we're not about moving data, we're about moving people. And I think that focus on trying to move communities and people, I think, has really been, the marker of success. And I think, Dan, you brought up an interesting point, and I think that's a good segue to Viet. So Viet, you've been all different kind of roles. You were practicing clinician for a bunch of years, then you went into industry, and now you're your own sort of boss. You've had a chance to explore and be part of many opportunities. But what do you see for students thinking about this? Like, what are sort of the market opportunities who for folks who develop expertise in this field of standards?
Well, I'll tell you, at least in FHIR, if you're a developer, take some classes and learn about FHIR and start building a few apps on your own, because everyone is looking for FHIR developers. And so what I've had to tell them is, you're not going to find a FHIR developer very easily. So train your developers, hire good developers, and train them in FHIR. That's one. I think the opportunity in informatics is huge, because you could come in from a very technical, or you can come in where we've come in as clinicians and informatics trained. So I think one of the key things in terms of skill building is the ability to connect. So part of what I do in consulting is connect policy to workflow, to applications, to data, to infrastructure. And so building those, that kind of understanding is really important. Learn how to work as part of a team. And know how you can support each other is really important. And then healthcare, as I mentioned, with the 18% of GDP, it's huge. And so there are a lot of opportunities to work in healthcare. You don't have to build the killer app, because I'm not actually convinced there is one killer app. But if you have skills that you can move from one domain to another, you can be a consultant, you can work for a company and be an analyst, you can be a developer. The standards development part, I would emphasize, again, what Dan and Abel said about part of the community. Figure out how you want to be part of the community, because standards development isn't for everyone. It's a bit nerdy, But what we're learning in HL7, I just got off a call with the board, is standards development is like the first mile of a 1,000-mile journey of specifications. The rest of it is getting the industry to adopt it, to mature it, and to implement it. So there's just a ton of opportunities, but just familiarizing yourself with FHIR and understanding the opportunities are great. We have, if you want to learn more, go to hl7.org. There's a Connectathon coming up in September. And if you go to that registration page, there's actually a link to a 3-hour FHIR 101. Which is FHIR US core testing and how to read an IG. And that alone is worth, what we give for free is worth like $500 in terms of training. So if you want to learn more, that's a great place to learn. And one thing for the developers and folks developing your apps, since that's what you guys are doing, don't start from scratch. I'm going to say tens or maybe hundreds of thousands of human hours have been put in creating the FHIR specification. Start there. Don't create a new data model. Leverage all this experience from the community, and that's one of the big contributions of HL7, making the specification Creative Commons so it's available to everyone.
Yeah, that 3-hour workshop you mentioned, so that's available. What we can do is we'll pull together some useful links as a follow-up to this, and make sure that gets out to the student teams. I think that's one of our big goals today too. So any other questions have popped in? I just wanted to make sure I didn't miss anything from student teams. For this part, we want to make sure that the friends and family discount while we have these people. So, all right, well, I will just ask one last thing, and that is like, so, we've heard a lot about data standards. So let's say you're a person who's really, I don't care about standards. I'm lazy. Somebody else does that work. Like it. So like, what do people who are really interested in like the AI, ML side of it, do they all have to also dive into these standards? They have to be facile in this, or is there some shortcuts or other ways to avoid this?
Yeah, I could take a crowd. Yeah, there's a lot of shortcuts. Yeah, it's easy. No, I think your question is a good one, because depending on the application domain, whether it's even within health, is a pretty big space. So the first thing I would say is it's really a team sport, and your expertise does not have to cover the entire waterfront, but you should for sure, and hopefully we tried to plant a few seeds here, recognize that there are dragons in there in a few different places. And so on your team, you're going to need some people who can understand the ways in which that data came to be, the flaws that might exist in the way that it came to be, particularly some of the comments we had earlier around being clear about the data collection in healthcare is actually a really, really important thing. There are all kinds of influences on how and what and where the data actually sort of gets stored that influence, what you can derive from it later. And so having people that have understanding of that sort of end-to-end cycle, I think is important. The last thing I would say, I found this paper and I thought it was pretty funny. So I'm going to pull it up here on the slide because they get an award for awesome title. I don't know if you guys try to submit journal articles, but try to come up with a title like this one. They used a quote that says, everyone wants to do the model work, not the data work. Data cascades in high stakes AI. The authors of this paper were trying to make a really important point. Hopefully it'll come up here. It's like data is the most undervalued and deglamorized aspect of AI. But yet, if you take it for granted, there's all sorts of sort of negative downstream consequences that could come. So I think, able to answer your question, I don't think that every person involved in AI needs to be a super data scrubber, cleanser, mapper, all of that. But that doesn't mean that it doesn't need to happen, that investment or understanding of the data quality and its standardization shouldn't happen. And as I described, you'll probably want to make friends with folks across disciplines who can help you kind of navigate those waters.
And I would reinforce what Dan said in terms of one of the challenges and the problems I've seen in healthcare and working in technology. It's the lack of appreciation for the fact that we are a system, and you got to have a systems approach to almost any project you do, because it's not usually about the technology. In the standard development, it's a lot about change management. How do you get the right people on board? Because if you don't have the CIO and the CMIO on board, because they don't appreciate it, that's not going to work. But if you don't have the nurses on board or the clinicians, it's not going to work. So I really like the notion of understanding enough to be able to appreciate a conversation on FHIR, and then add your expertise so that you can connect the dots.
That's great. And then I think Kevin had one question as well. We could maybe just unmute Kevin just for a second.
You're unmuted, Kevin.
Or if not, I'm going to paraphrase.
Oh, his mic is broken, he says.
Okay, that's easy. All right, so he just asked about FHIR support for patient-generated data and wearables, and the kind of interest there might be from industry in this area. So it's a FHIR question. So Viet, I don't know if you have.
I think there's a lot of interest, and partly around that social determinants of health, that gravity work, because patients know their situations the best. And so being able to capture data about their social determinants, like their housing insecurity, food insecurity, those are kind of things you would want to know about the patient around social determinants, but also things that Dan's worked on around LOINC. How do you represent a questionnaire around depression screening? That's patient-generated data. And so being able to implement and use FHIR and the various like LOINC standards and put them into FHIR, and then use that in a user interface that's in a mobile app, there are lots of really good opportunities, because not only to allow the patient to monitor their own care, which is great, but to share that information with a provider through those smart on FHIR apps is really going to be important for chronic care, particularly.
And then Dr. Teji had another question, and actually this is interesting. It's how is HL7 FHIR related, I guess, to the National Center for Health Statistics birth certificate data?
Yes, I use this data daily to have, I have like 135 million births in the US and has maternal data. I play with that every day. And how is the FHIR, your FHIR, related to that? I just went to the HL7 website, and there's some death certificate data, but is the birth certificate data, which, I was designing some ROC curves for the newborn death.
I don't know.
35 variables.
Yeah, I don't think they've developed the FHIR implementation guide yet for that, but I'm very hopeful, because the CDC is we're hoping in a very near future going to announce the start of their public health FHIR accelerator. It's been delayed because of all the same reasons we all know, and so they want to tackle those kind of standards as well.
Excellent, very good. Yeah, I've been using for the last 15 years. It's wealth of data. Thank you very much for your answer.
For such important events as coming into the world and leaving the world, the data around those events are actually very, very poor. And so even without the wrapper or the FHIR wrapper around the implementation of the guides, like the underpinning data certainly on the death side, because I'm an adult medicine person, is really poor, as you may know. So even what's in NCHS, CDC death data from the certificates, for anyone who's been a practicing clinician, we all know those death certificates are oftentimes poorly filled out or fairly non-standard in how they're filled out. And so actually identifying things like cause of death for something as important as death is really remarkably poor, it turns out.
That actually was something that the CDC worked on. Georgia Tech, they had some students working on it where they were analyzing EHR data around death certificates and mining them to see what were all the other potential contributors. And the idea being that if you had a clinician could use an electronic form connected to the patient's EHR record, they could offer up, did you know that this patient had, underlying renal disease and things, to make those death certificates more rich.
Yep. And
the problem is that people use different types of data. They are creating databases after data, but each patient has just one database. If you could just use that for every application, like filling out the VIC form or physical exam for children, it's just all you need is one solid data.
But getting everybody to agree on those elements is part of the challenge.
Yeah, I agree with you.
And it seems like it's harder now more than ever. So
Yes.
So excellent points. Other questions or comments from the audience? Great. Well, in that case, I just want to take the time to thank Dan, Viet for fantastic presentations. I always enjoy, even though I am the choir, I always learn something from you guys when you guys give talks. And it's always fun working with you. So I look forward to our continued work together. And on behalf of myself and our students and our team, thank you very much. And thanks for everyone who participated today. Thank you.
Thanks for the opportunity. Good luck to the students in your development.
Great,
yes,
thank you.
Thank you so much. It was a pleasure.
Thanks, guys. See you. Bye.